Wood has been woven into our lives from the start. It's in the houses we were raised in, the kitchen tables where families came together, and the old bridges that carried whole communities for decades. For most of us, it was just there. Constant, dependable, so ordinary that we rarely paused to wonder where it all began. Back then, logging was a whole different world. Workers swung hand saws and double-bit axes, fighting just to drag timber out of the forest. It was slow, brutal work, and most of the tree never made it to use. The tops, the bark, the uneven cuts, the mountains of sawdust, all left behind. More than 70% of every tree was wasted. That was simply how things were. Today, the story couldn't be more different. Modern mills scan each log with lasers, map it with computers, and slice it with pinpoint accuracy. In just seconds, almost 100% of every tree is put to work. From tough beams and framing lumber to pellets that keep homes warm through winter. Nothing is thrown away. And the scale of the industry is just as staggering. In the United States alone, wood and forest products bring in around $288 billion every year, roughly 4% of the nation's manufacturing GDP. It's an incredible transformation, from sweat-driven hand tools to high-tech efficiency and sustainability. And this evolution is still unfolding. Stick with Iron Age as we track wood's journey from the forest all the way to the finished product. Deep in the forest, the journey of every piece of lumber starts with the moment a tree comes down. The faller carefully chooses the direction, then cuts a V-shaped notch at the base, known as the undercut. That notch works like a hinge, guiding the tree as it falls and protecting both the crew and the valuable wood inside. Then comes the back cut, a horizontal slice made just above the notch. On paper, it sounds simple. But when you're working with trees 3 or 4 feet thick, nothing is ever that straightforward. That's where the old-school skill kicks in. A seasoned logger knows how to widen the notch or open a window to release the holding wood still gripping the stump. He reads the tree like a doctor reads a patient. The groan of the fibers, the sharp crack of the hinge beginning to give way. And when that massive cedar or hemlock finally leans, tips, and slams into the forest floor, you know you've just won a small battle with nature. For the real giants, the tool of choice is still the gas-powered chainsaw, running 36 or 42-inch bars with chains tuned precisely to the wood. Too sharp, and the chain digs in too aggressively. Too dull, and harder woods like hemlock fight back. And cedar fibers can choke a saw if the chain isn't just right. Getting that perfect edge takes hard-earned judgment. Do you remember that sound from your younger days? The deep, chest-shaking thud of a tree hitting the ground and rolling through the valley like distant thunder. Alongside the skill of traditional hand felling, modern forestry leans heavily on machines that deliver productivity and safety at levels earlier generations could only imagine. These systems don't just bring a tree down. They process it right on the spot, stripping limbs, cutting precise lengths, and eliminating risks that once cost time and even lives. Across Europe and North America, 2 machines rise above the rest. The harvester, armed with its hydraulic cutting head, grabs a tree, slices it free, strips the branches, and cuts it to length in minutes, all while logging diameter and measurements for managers to track. The feller buncher is built for pure speed, mowing through multiple trees and stacking them into neat bundles ready for skidders or trucks. Each of these machines can replace a crew of 10 to 15 men, transforming how forests are worked. And still, when a giant reaches more than 30 inches across, the old-school faller with his chainsaw remains the one who calls the shots. Logging and forest services in the U.S. generated $21.6 billion in 2022. But the real value lies in sustainability. Managed forests ensure that every tree harvested is part of a continuous cycle of regrowth. Once the tree is down, it's limbed, measured, and skidded into a deck, ready for the next stage of its journey. The next challenge is hauling thousands of pounds of timber across rugged, unforgiving terrain. On steep terrain, cable yarding systems take over. Steel lines stretched between towers or anchored to tall trees, pulling logs up slopes where trucks can't reach. A single yarder can do the work of dozens of tractors while keeping crews safer on the ground. On gentler ground, skidders are the true workhorses of modern logging. With grapple arms or winches, they haul multiple logs at a time, dragging them to the landing with speed and efficiency, cutting both time and cost. And wherever a road reaches the forest, trucks take command. Oregon alone ships over 3.5 billion board feet of lumber every year. And across the United States, more than 100,000 logging trucks keep the supply chain alive. But before trucks and highways shaped the industry, America's rivers carried the weight of its timber. For much of the 20th century, entire rivers were jammed with floating logs. Men in spiked boots balanced on rolling timber, guiding it with pike poles while the current did most of the work. But by the 1970s, concerns over salmon runs and the health of river ecosystems had largely brought U.S. log drives to an end, leaving only small-scale or heritage demonstrations as echoes of a tough, once-thriving culture now fading into history. You might be surprised to learn that long before modern highways, logs also traveled by rail and by massive cranes built specifically for the forest. This was the era of the logging railroad. By the 1920s, the United States had more than 40,000 miles of track laid purely for timber, winding deep into valleys no road would ever reach. Entire trains loaded with logs rumbled out of the woods each day on their way to the mills. At river landings, overhead cranes and highline loaders swung whole stems onto barges headed for the coastal sawmills. Even today at certain ports, gantry cranes still unload Canadian and Alaskan logs directly from ships. And while most of these old transport methods have disappeared, they're a reminder of just how expansive and inventive the logging industry once was. After the long journey from forest to mill, the real transformation begins. Logs are also scanned for hidden nails or wire, because a single hit of metal can ruin a saw blade in an instant. One of the most crucial jobs in the mill is the saw filer, the specialist who keeps every blade razor sharp. It's a blend of art and science, ensuring clean cuts and keeping the entire operation running smoothly. Before a blade ever touches wood, modern lasers sweep across the log, building a full 3D model in seconds. The software lays out exactly where each cut should go for maximum yield, almost like a blueprint for profit. Then, the head rig steps in to make the first major cuts, all under the control of the sawyer. From a high cab, he takes that round log and squares it into a cant, a solid block that will eventually become dozens of boards. Precision positioning systems line up every log perfectly before the cut, giving the sawyer an ideal start every time. The first cuts open up the log, but many of the boards then move through secondary resaws, which use thinner blades to recover even more usable wood. A big reason today's mills are far more efficient than those of the past. The outer slabs, too thin to make boards, are sent directly to chippers, where they're turned into pulp or fiberboard. Once the cant is squared, it heads into the gang saws, where multiple blades slice out several boards at the same time. A roar of steel turning solid blocks into lumber. Newer curved saw systems push efficiency even further. Instead of forcing straight cuts, they follow the natural sweep of the tree. That simple shift recovers 5 to 10% more wood, adding millions of board feet every year in mills that run non-stop. Boards fresh off the saw still have rough, uneven edges. Edgers shave the sides clean, making them straight and uniform. At the trimmer, operators cut each board to standard lengths, 8, 10, or 12 feet, while removing defects by trimming a foot or two off the ends when necessary. From there, the boards head to sorting and grading stations where their final value is determined. Fresh lumber is still green, holding nearly half its weight in water. To keep the boards from twisting or cracking, mills dry them down to roughly 12 to 19% moisture. Some boards are air-dried outdoors for months, but most today go into massive kilns, giant ovens that can season lumber in just a few days. Even after drying, the wood still feels rough, so mills send it through planers to smooth the surface and bring every board to a precise, uniform thickness. Once the boards are smoothed, they're graded for quality. Straight grain and clean faces earn the highest marks, while pieces with knots or natural bends are set aside for applications where strength matters more than appearance. Some mills now rely on cameras and computer vision to grade lumber. These systems scan hundreds of boards per minute, detecting defects faster and more accurately than the human eye, helping mills keep pace with today's demand. At this stage, indoor lumber is ready for the market, ideal for studs, flooring, or cabinets. But boards destined for outdoor decks or fences need one final step: pressure treatment to protect them from weather, insects, and rot. Every log that passes through the mill gives us more than just lumber from that first slice. Nothing goes to waste. Even the bark peeled off the logs gets ground up and turned into landscaping mulch, finding its way into gardens and parks instead of being burned or thrown away. Any pieces that can't be turned into lumber are chipped down and sent off to paper mills or used as the core material for fiberboard. Even the finest sawdust gets collected, blown into silos, pressed into briquettes, or sold as bedding for livestock. In a modern sawmill, the leftovers form an entire economy of their own. One of the biggest byproducts is fuel pellets. By compressing sawdust down to about 7 to 10% moisture, mills produce a fuel that burns hot, steady, and clean. Those pellets now heat homes across the northern states and are shipped around the world. In 2024 alone, the U.S. exported over 10 million tons, making it the global leader. But as many homeowners know, pellets aren't always cheap. Burning through 6 tons in a single winter can run into the thousands. Beyond pellet stoves, wood chips feed boilers, power generators, and even support research into turning sawdust into methanol, a renewable liquid fuel. Today, more than 95% of mill residues in the U.S. are reused. Customers and regulators increasingly demand proof of responsible sourcing, and mills have stepped up. As operators like to say, nothing goes to waste in a sawmill. That's the cycle. From forest to lumber, from mulch to pellets, every part of the tree finds its purpose. It's how modern wood production stays both efficient and sustainable.